Number 15 from the Larsen worksheet, and this is another one of these pesky partial fractions. So again, we have 2 over 1 minus x squared, and this factors to be, or we can rewrite this as 2 over, and this bottom factors to be 1 minus x times 1 plus x. And again, we have a over 1 minus x and b over 1 plus x. And my center is going to be 0, so I'm in good shape. Excuse me. So now we can just use our partial fractions, a times 1 plus x, b times 1 minus x, all over this denominator equals 2 over the same denominator. So since the fractions are the same, the numerators will be the same. So again, this is what we have. So by selecting good values of x, this will cause the a term to vanish, and we have 1 minus negative 1 is 2, so 2b equals 2, b equals 1. And then when x equals 1, the b term will vanish, and we have 2a equals 2, so a also equals 1. So there we go, and these are very, very close to what we want. Real handy. This actually is the geometric series. It's already set up, and this is just with the negative sign. So we lucked out, and again, our center is 0, so we're ready to go. So we can write this as x to the n, the summation, n equals 0 of the geometric series, plus negative 1x to the n. And then we can factor out the x to the n, and we have this. And again, they both have the same interval convergence between negative 1 and 1, so that's our interval convergence. That's the intersection. Now, this is kind of interesting because this looks all right, but if we write out a few terms, sometimes we can see a pattern that will be a little bit more, make a little bit more sense, or a little bit easier to describe. So what we could do is we could try some values for x for n equals 0 to infinity. So if I put 0 in here, I got 1, and then negative 1 of the 0 is 1, so 1 plus 1 is 2, so I've got 2 times x to the 0, which is just 2 times 1. But if I put 1 in here, I get 1, and negative 1 to the 1 is negative 1, so that's 0. So 0 times x just becomes 0. And you can see what happens if I put 2 in here. 2, and that's just going to be, I'm sorry, if I put 2 in here, this is going to be 1, and this is going to be squared. So that's going to be negative 1 squared would be positive 1, so I got 1 plus 1 is 2 again, and x to the second. And if we keep putting numbers in, we get this pattern. N equals 3, n equals 4, n equals 5, n equals 6. Every other one of the terms disappears. So it ends up being 2, 2x squared, 2x to the 4th, 2x to the 6th. So this is a new series that I can kind of describe, and I can describe this now using this as the 0 term, the first, second, and third, and I can describe this like this. And if you have a 2, and you can actually see it's a geometric series, and the a is 2, and the x to the n is x squared. So it'd be 2 times x squared to the n. See, because I keep multiplying 2 by x squared, 2 by x, this by x squared by x squared. If I don't multiply, in other words, I start with 2. 2 times x squared is this. 2x squared times x squared is 2x to the 4th. 2x to the 4th times x squared is 2x to the 6th. So you see, we could kind of write, this is actually another geometric series, but it makes it a little bit nicer to write it like this than with this configuration, because we can actually get the terms faster. So this is a good thing to remember. So whenever we see this combination, try to remember that you can write this out and make it a little bit easier to deal with. So that's number 15.